Hi, welcome to the Calculus 2 lecture series. And we are in the unit number 4, talk about the sequence and the series. This is a pretty big unit. And we are in the lecture number 19. This is the second video about the lecture number 19. We are talking about the alternating series. Okay, so on the first video, we talk about, we start the introduction of alternating series. We give the definition about the alternating series. And also we introduce the alternating series test for the convergences here, all right? So in this video, we're going to talk about how to estimate the sum of alternating series. Okay, so let's go ahead, go to our lecture notes here. So, like in the introduction I mentioned from the previous video, we give the definition about what is the alternating series and what is the alternating series test here. So for this video, we're going to talk about how do we estimate, the sum of the alternating series estimations here. Okay, so let's try to write here. So we say if the summation n from 1 to infinity, and this is -1 to the n minus 1 to the an, is an alternating series. Okay, so it's an alternating series, and this series converges to converge to S here. So we know alternating series, if it's a convergent series, right? So we say this has to be a decreasing, AN has to be a decreasing sequence. So AN has to be less than, AN plus 1 has to be less than AN. And also we know the limit of what n approach to infinity, the an is going to approach to what? Approach to zeros, right? So I know the rn's here, right? So if you take the absolute value of the rn will be the absolute value of s minus sn's here. All right, and this one's here because the absolute values, right? So this one going to be less than or equal to what? Equal to the an plus 1. Okay, so this one is really pretty straightforward. It's pretty easy. So so let's take a look here, right? So your series is a1, then the minus a2, a3, minus a4, and now here, then the a5 minus a6, right? And da, 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 da. Okay, so now let's take a look here, right? So if the, like we said, the S here is you adding from here all the way here to S here, right? So let's say the S5 is here. Let's say the S5 is from here all the way add to here. All right, so the S minus S5, right? So S minus S5 will start out with what? So this will be negative A6, right? So let's write a few more terms. Then you will have what? A7. Then you have a negative 8, 8, da, da, da. So you know that here they always have that because this is a decreasing sequence. So A7 going to be less than A6, AA going to be less than A7, right? So I know the S minus, right? So like if you use the S minus Rn, so it's going to be, so here going to be the A6. But then behind it, they have like the positive, negative, they will cancel it out. So the largest one, that's why the upper bound here will be a to the n plus 1. Right, so from here it's kind of obvious to see that. So if you use the S's, the everything, the green minus A5 here, then what is this value? If you take the absolute value of this, that will be less than the A6. That's why it's AN plus 1. Okay, so now let's take a look here. Show that the series is a convergence here. So the first thing here, the convergence here, this is the alternating series, right? And then I know the an is equal to an plus 1. And then the an plus 1 is n plus 1 plus 1. Right, so this is an plus 1. So I know the denominator of an plus 1 is greater than, so it's go this way, right? So an is greater than an, so I know an is what is decreasing. Right, now if it's decreasing, now limit n approach to infinity an will be equal to the limit n approach to infinity 1 over n plus 1. Right? So what is this one going to be? This one's here going to be what is going to approach to 0, right? So then I know that this series 1 from n to infinity, and this is the n plus 1, negative 1 to the n, converges here. Why? By the alternating series test, right? Okay. Okay, now let's say estimate the sum of the series and the 15th. All right, the 15th partial sum. That means I'm estimate S minus S15. So by what we just say here is what is this remainder going to be? Is less than an to the plus 1. So that means this one's here is going to be less than equal to what? A16. So what is A16 here is just 1 over square root of the 16 plus what? Plus 1. So it's 1 over 5, right? So it's 0.2. That means, that means the S minus S15, right, is less than or equal to the 0.5. So that means S minus S15 cannot exceed, right? Cannot exceed what? 0.2. That's the upper bound for the arrows here. All right, so now let's take a look. The next one's here, let's say for what value of the n, if I want to find the partial sum, then the partial sum is within the 0.001, right? So it's 0.001 of this series. And we know this is, by the alternating series, we can test this is a convergent series, right? Because here first you have this negative 1 to the n plus 1. Then I will say the an is equal to 1 over 2n plus 5. And then the n plus 1 is 2 the n plus 1 plus 5, right? So this is an plus 1. So obviously this denominator is bigger than 2n plus 1. So that's why an greater than an plus 1. So that's why I know the an, this is what is decreasing, right? It's a decreasing sequence. All right, so then the next thing here we say limit n approach to infinity an is equal to limit n approach to infinity 2n plus 5. So n go to infinity, what is go to here is 0. So I know this sequence is what is converged, right? So this is converged by what? By alternating series test, right? That's what the series test. Now I want my partial sum within the 0.001. That means S and minus Sn, right? So it's going to be the less than equal 0.001. And also from while ago we say S minus Sn is length is what? A to the n plus 1, right? So we know the n plus 1, so that means an plus 1 will be what? Is 2 the n plus 1 plus 5, right? So will be less than 0.001. So that means this is 2n plus 7, right? So the 2n plus 7 is less than equal to 0.001. So that's why I get 2n plus 7 greater than 1 over 0.001, right? So that means 2n plus 7 is greater than equal to 1,000. Okay, so let's so I can have the 2n greater than equal to 993. So n is greater than equal to 496.5. So n, we said is equal to the 497th, right? So that means, so if we want to estimate the partial sum of this within the 0.001, we need to use the partial sum for how many? 497. All right. So so we know that S, the 497, this number is within the 0.001 of whatever the true sum when you add all of them together here. All right. So number 5 is here. They said approximately, approximate this to the sum 0.005 here. So which partial sum I need to use, right? So this is the same thing here. So this is the convergence because 1/3 limit an approach to zeros, right? So I know that then the same things here. I said S minus Sn, and this one is less than equal to what? An plus 1, and is less than equal to 0.005, right? So the an plus 1 is what? An plus 1 is n plus 1 to the how many? Cube power, right? Is less than equal to the 0.005. 0.005, in fact, is 1/200. So you can find that it's n plus 1 to the cube is greater than what? Greater than 200. Then the n plus 1 is greater than like 200 to the 1/3, right? So 200 to the 1/3 is close to the 5.84. Okay, so I know the a plus 1, so that means n is greater than equal to the 4.84. So we can that the n equal to 5. So I know the S5 will give me a number pretty close. So let's take a look at what is S5 here. So S5 will be n equal to 1 is 1, and n equal to 2 is minus, right? So it's 2 to the 3rd. N equal to 3 is a plus again, so it's 3 to the 3rd. N equal to 4 is 4 to the 3rd plus 5 to the 3rd, right? So if you add them together, then this one is very close to the 0.9044 here. Okay, so we don't know. So how do we set here? We don't know what is this series add to, right? But we know, 0.9044 is within what? Is within the 0.005 of the series sum, right? Series sum S. We don't really know what it exactly is the S, but we do know if you use S5, 0.9044 is within 0.005 of the series sums here. All right, so let's take a look at another one. So they say use the 15th partial sum to estimate how accurate for this estimations here. All right. Okay, so how accurate for this, like so basically you just do S15s, right? So when n equal to 1 is what? Is 1. N equal to 2 is what? N equal to 2, so it's minus 2 to the 3rd, and here, right? And then n equal to 4 will be 4 to the 3rd to the, right? So it's positive. N equal to 1, 2, 3. I'm sorry, this is 3, right? So n equal to 3. So it's positive. So you add all the way when n is equal to what? 15 here. So it's 15 to the third. So 15 minus 1 is 14. So it's a positive 1 over 15 here. So if you add all this together, it will become pretty close to what? 0.90169 here. So let's say how close to the sum. So I know the same things here. How close? This will be less than equal to what? A16, right? So the A16 here, the absolute value of the A16, right? So the A16 is what? Is 1 over 16 to the what? To the third. So these ones here will be very close to pointer 00024. Okay, so we know the S15 is equal to what? Pretty close to the 0.90169, right? We say it's within 0.00024 of the sum of the series. Okay, so this one's here is pretty, the alternating series. That's why I told you at the beginning I like alternating series, right? So like in here, so this is a pretty handy formulas, right? So this is the upper bound for the estimations here. All right, okay, that's it. And the third video, we're going to talk about the alternating series. Is we're going to introduce what is the absolute convergence and what is the conditional convergence here. All right. Okay, nice talk to you and looking forward to talk to you in our next videos here. Okay, bye.